The park is mapped. The impossible locations are eliminated. The key factors are identified. The uncertainty is quantified. Now the rescue team needs data, real evidence from the field, to narrow the search from a 5-kilometer circle to a specific valley. Before deploying the rescue team, the search commander runs a simulation. 1,000 virtual hikers at different walking speeds, different decision-making tendencies, different levels of panic. Drop each one at the last known position and simulate their movement. Where do they end up? 80% cluster near water sources, rivers, streams, ponds. Lost hikers seek water. It's a survival instinct. The simulation generates a population-level prediction. Search near water first. PyABC begins with a prior, the best guess before any field evidence. Based on the LHS exploration, sensitivity analysis and virtual population, the hiker is somewhere within this 5-kilometer radius, most likely near water, weighted toward trails. This circle is the prior distribution. It's informed but still wide. Many valleys, many possible locations. The first field team radios in, fresh footprints near the southern trail junction. A second team finds camp debris, a torn rain jacket caught on a branch. A third team discovers a discarded water bottle by the creek in the western valley. 3 pieces of evidence, 3 data points. Each one constrains the search. The footprints say south. The debris says the hiker stopped. The water bottle says the creek. PyABC combines the prior with the evidence. The wide 5-kilometer circle fades. So a region emerges, an ellipse centered on the western valley near the creek, south of the trail junction. The posterior distribution. Not the entire park. Not the 5-kilometer circle. This specific valley. The rescue team converges. And there, by the creek, sheltered under a rock overhang, the hiker is found. The full pipeline. Step 1. LHS explores the parameter space systematically. Step 2. Behavioral filtering eliminates impossible regions. Step 3. Sensitivity analysis identifies which factors matter. Step 4. Uncertainty characterization quantifies the range. Step 5. PyABC uses evidence to narrow from prior to posterior. Without the LHS exploration first, the rescue team would waste time searching cliffs and lakes. They wouldn't know that distance and trails are the key factors, and they wouldn't know whether to search 5 kilometers or 50. The exploration enables the rescue. Explore systematically with LHS, filter the impossible, focus on what matters, quantify the uncertainty, then rescue with data. The lost hiker is found not by luck, but by method. Every step in the pipeline made the next step more efficient. That's how computational modeling works: explore, filter, focus, quantify, and converge on the truth.